Okay, let's dive into something pretty wild. We're going to talk about a totally new way of thinking about robotics, one that completely ditches the idea of a single powerful brain. Instead, it taps into the collective genius of a swarm.
I know, this sounds like something straight out of science fiction, right? But believe it or not, it's happening as we speak. And the secret? It's not some brand new supercomputer or a crazy complex algorithm. No, it's an idea that's, well, way older.
I mean, you've seen this in nature, right? Picture a huge flock of birds, just creating these amazing flowing patterns in the sky. Or a school of fish that moves like a single living thing to dodge a predator. It's beautiful, it's complex, but how on earth does it happen when there's no leader? No one's calling the shots.
Well, there's a name for this. It's called emergent behavior. And it's this awesome paradox where the group becomes way smarter than any single individual in it. You know, each one isn't a genius on its own, but when they work together, boom, you get something that looks a lot like genius. And that right there is the secret sauce we're now putting into robots. So if you want to find the best blueprint for this kind of collective intelligence, where do you look? Well, you look to one of nature's OG master engineers, the humble ant. Seriously, the solution that ants perfected millions of years ago is now sparking a full-blown revolution in robotics.
Okay, here's a word you're going to want to remember. Stigmergy. It sounds a little complicated, but the idea behind it is just brilliant. It's basically how ants communicate without ever talking to each other. They don't need to. They use the world around them as a giant message board. One ant does something, leaves a little clue in the environment, and the next ant comes along, reads that clue, and knows exactly what to do.
Let's see how this actually works. So picture this. One ant is out exploring and it finds some food. On its way back to the nest, it leaves behind this chemical trail, a pheromone trail. Pretty soon, other ants pick up on that trail and start following it. Now here's the clever part. The ants using a shorter path can go back and forth more times, right? So that shorter path gets reinforced with more and more pheromones, making it stronger and more attractive. It's this beautiful, simple feedback loop that over time leads the entire colony to the best, most efficient route, and nobody ever had to give a single command.
Okay, so that's the genius of the ant colony. The billion-dollar question for robotics engineers is, obviously, how do we copy that? How do we take that incredible natural system and turn it into code for our machines?
The difference is pretty huge. Think about a centralized system. It's like an old-school cloakroom. You've got one person in charge, a single list of all the tickets and codes. But what happens if that one person goes on break, or the list gets lost? The whole system just grinds to a halt. It's a single point of failure. Now, a decentralized swarm is like a smart cloakroom. You can hand your jacket to any robot. It finds a spot. And when you want it back, they just figure it out together, in real time. There's no big master list, no single point of failure. If one robot goes down, the others pick up the slack.
So it all boils down to these core principles, right? You've got decentralized control, simple rules for each robot, and from that, you get that amazing emergent behavior. What this gives you is a system that is, first, super robust and flexible. But here's the other magic ingredient, scalability. You can go from a team of 10 robots to 10,000 robots, and the system doesn't even blink. Why? Because there's no central brain to get overloaded. It just works.
And look, this isn't just some cool idea that scientists are kicking around in a lab. This is happening right now. Swarm intelligence is already out there, being put to work in some of the toughest, most complex industries you can imagine.
I mean, we're talking about everything from logistics and making sure your packages get to you faster, to search and rescue missions where swarms can go into places that are way too dangerous for people. Basically, anywhere a single, super expensive complex robot would struggle, a swarm can thrive. It's popping up everywhere.
And when we talk about scale, it can get absolutely mind-blowing. Look at this number, 10 to the power of 13. That's 10 trillion. No, that is not a typo. Right now, researchers are designing swarms with that many nanoparticles, all designed to work together inside the human body to find and destroy things like cancer cells. Just let that sink in for a sec.
Let's bring it back to that online order you made. You were seeing Stigmergy in action every time you click Buy. In those giant warehouses, like the ones Amazon uses, you have fleets of robots. They don't leave chemical trails, of course. They leave digital trails. They mark busy routes or where an item is located in a shared digital map. The other robots see these digital breadcrumbs and change their own routes to be more efficient. The whole system works together to move millions of items a day. It's ant colony optimization, but for your packages.
Or think about a massive problem like wildfires. Imagine a swarm of drones, hundreds of them, patrolling an area as big as California. They never sleep. They work together 24/7. And the moment one of them spots a tiny spark, just the beginning of a fire, the whole swarm can coordinate and alert the authorities instantly. It's like having a living, self-organizing fire shield protecting the entire state.
So that's what's happening today. It's already incredible. But what about tomorrow? Where is all this heading? Well, the stuff that's coming next, it's really going to change our world in ways we probably can't even fully grasp yet.
And this isn't just wishful thinking. This roadmap is based on what researchers are actively developing right now. We're talking about swarms exploring the moon and Mars within the next decade, tiny, soft-bodied swarms cleaning microplastics from our oceans, and eventually, those microscopic robot swarms becoming a real medical tool we use to heal ourselves from the inside. This isn't science fiction. This is the future they're building.
The potential here is just staggering. It's incredible. But it also forces us to ask a really big question. We need to completely rethink how we interact with technology. For our entire history with machines, it's been about command and control. We tell the machine what to do. But this is different. This is about partnership, about collaborating with a collective intelligence. So the real question we're left with isn't just, what can these swarms do for us? It's, how are we going to learn to work with